All right, terminating and repeating decimals for this practice test. We also went over classifying numbers. We started with natural, whole, integer, rationals, reals, all of those are reals, and we also went over irrationals. So write each fraction or mixed number as a decimal using bar notation if the decimal is repeating. All right, so this problem, we've seen several like this before. This one is 5 divided by 8. Now on this part you won't be able to use a calculator, so I'm going to go through the math on this one with the division. So 8 will go into 5 0 times. So I'm going to have to make that a 50, so I'm going to look into my decimal values, right account. Alright, 8. How many times does it go into 50? 6 times. 6 times 8 is 48. And I subtract, and I get a 2, which means I need another 0 to drop into this. 8 goes into 20 twice. Alright, 8 goes into 20 2 times. 2 times 8 is 16. Subtract, and I got a 4 left over, so I'm going to drop another 0, because 8 won't go into 4. But it will go into 40 5 times. 5 times 8 is 40. Subtract, and we got 0 remaining. So this is the decimal, which in this case, you could show that it repeats as 0, but it's not necessary because it really just terminates. This one is 2 divided by old 9er. So I got 2 divided by 9, which will not go into 2. 9 will not go into 2. So 9 doesn't go into 2, but it will go into 20, so I'm looking at decimal value. It will go into 20 exactly 2 times. 2 times 9 is 18, so when I subtract, I got a 2. That's the number I started with, so the 2 just repeats.
Oh yeah, I have a...
Here we got 37 divided by 16. This could have been written as a mixed number, but we got an improper fraction. That's okay. 16 will go into 37 twice. 2 times 16 is 32. And I subtract, and I got 5. Well, 16 won't go into 5, so I'm going to tack on another 0 and make that 50. So 16 will go into 50 3 times. 3 times 16 is 48. Minus, and we get a 2. Alright, 16 won't go into 2, but if I drop a 0, it will go into 20. So, I'm going to have to extend that. 16 will go into 20 once. 1 times 16 is 16, subtract, and I get 4. So, I will need another 0 to drop. 16 will go into 40 twice. 2 times 16 is 32.
Can I do number 13 for you too?
Alright, so we do need another 0. And it will go into 80 exactly 5 times. 5 times 16 is 80, so that is where it stops. So the answer on this one, 2.3125. So this one, negative 3/4. We just need to know the answer is negative because of the negative radical. And then we got 3 divided by 4. We'll just show the work for this one.
What kind of stuff do you want?
Alright. 0.75, but it's negative, right? Because I had the negative outcount. So, what I will do is I will just write it up here.
Are you and Mr. Wood like that?
Finish this. That's a 0.75. Right, Cal? I'm going to do this one a little differently. Alright, good luck.
Okay, so first we have to do 27 divided by 50. And so 27 goes into 50 0 times. So do that. Oh wow, it's all off now. I gotta do that. And so then you have to bring another 0. And then 50 goes into 275 times. So 5 here. minus 250, and then minus 20, and then bring another 0, and then 50 goes into 200 4 times, and minus 200 is 0. So that's the answer.
Very nice.
Yo, quick maths right here. Right here, gonna do some
Good
quick
luck.
maths. Okay, cause you know. Okay, 25 times 4, and then 121 times 4. That equals 484, and then we got that fraction, dude. And then 25 times 4 equals 100. And this can be changed into a decimal. So we can just move this decimal 2 points to the right. And then there we got 4.84. Boom! 4 and 84 hundredths.
Boom.
Quick maths. Men's not hot.
Bam. So we will change this into a decimal, and it's negative, so I'm just going to put that out front. And it doesn't have a mixed number, so we got 0 point something. Then we're going to do 5 divided by 6. Well, 6 doesn't go into 5, that's where that 0 came from. So we're going to look at 50. 6 goes into 50 8 times. 8 times 6 is 48. We subtract and we get 2, so we need to drop another 0. 6 goes into 20 3 times. 3 times 6 is 18, and when we subtract right account, we get 2. Well, we just got a 2, and what did it give us? A 3. So that means if I dropped a 0 right account, it would give me another 3, and the 3's repeat. Bam. Alright, so that is the answer, negative 0.83 repeating. So on this one, we have 1 divided by 33, and 33 won't go into 1. It won't go into 10 either, but it will go into 100 3 times. 3 times 33 would be 99, so we're going to subtract and we get 1. And some of you guys know that means that it's going to start repeating, but we got to be careful with what repeats right account. Because if I drop a 0, it's not going to go into 10 just like it didn't for this 10 right account. So it's going to drop another 0, and that's where the 3 will repeat. So it's 0 3's that repeat, and our answer is 0.03 of repeat. So number 9er, this is 62 divided by 11. 11's a pretty easy one usually to work with. 11 goes into 62 5 times, so that's a 55 right account. Subtract, we got 7. So we're going to need a decimal place to drop a 0. 11 will go into 76 times, so that's a minus 66, which gives us 4, and then we'll drop another 0. 11 goes into 43 times, so that'd be 33, and that'd be 7, so we'll drop another 0. But you guys see we got the 70 right there, right? So I mean, we could go a little bit further just to see where it repeats, but that's going to give us another 6 right account. So we'll subtract 66, drop it, get a 4, drop another 0, and that will show the 3. So it's the 6 3's that are repeating. So the final answer, right account, 5.63 repeat. Two-thirds on these. So it's 2 divided by 3. This was a more common one. 3 does not go into 2, but it will go into 26 times. So when we subtract the 18, we get 2. That's what we started with, 2, so the 6 repeats. Bam. Number 11, we're going to do this one like we did with the other class. I can make 40 a 100 by multiplying this by 2.5. So what that does, actually that's going to give me a decimal. I don't want decimals, so that's no good. Alright. Alright, now again, this one's a negative, so we're going to make the decimal negative. And we got 11 divided by 40, which does not go into 11. So we're going to need a 0 radical. 40 will go into 110 twice. So we're subtracting 80. And that gives us 30 radical. So we're going to have to drop another 0.
8 times.
It will go in, 40 will go into 30, 300 rather, 7 times.
What?
So 7 times 40 is 280. Then we'll drop that and get 20. So I need another 0. And 40 goes into 200 5 times. 5 times 40 is 200. So when we subtract, we got 0 remaining. That terminates then. And our final answer is negative 0.275. Bam. Alright, 12 will work though. On this one, if I multiply this by 5 and 13 by 5, I'll get two whole values. Specifically though, I need that denominator to be some base 10 value so that I can change this into a decimal. 13 times 5 would be 65. So as a decimal, this is 65 hundredths. So I just make the 5 the hundredths position. 0.65, done. That's a different method, but it still works. These two will work the same way. If I multiply 5 by 20, then I will get a hundredths position. So in my decimal, I'm going to have two place values. And I showed a ones position right here, but it could be more than that. Let's find out. So 83 times 20. Now, it's not that you have to do it this way, it's that you can do it this way. And since we did a lot of long division, you guys are usually pretty bored with it by now. So here's something different. 83 times 20, 0 on that too. So this would be 1660 hundredths, so we do have a tens value. But it's more important to see that this is the hundredths. So 16.6 will work, or 16.60. So either one of them will work. There it is. This one's a little bit easier because we're just going to multiply 10 by 10 to get the hundredths. And again, that's the place value of the number in the numerator. 3 times 10 is 30. Some of you guys don't need that, alright, because the tenths is the tenths value, which would be right account. 3 of these tenths. We made it 30 hundredths, which would just be this. I put the 0 in front though, so that will work, or 0.3 will work. Alright, so again, this answer will be negative, and I got 1 divided by 9er. It doesn't go into 1, so I got to make that a 10. It goes into a once. 1 times 9 is 9, and we got 1 remaining. That's what I started with. 0.1 repeating, negative 0.1 repeating. I did it. Alright, here we go.
You were so mean to me.
So this is 111 divided by 24. 24 will go into 111 4 times. So that gives us a 96. And I got 15 remaining after I subtract. So I am going to need the decimal value right up in count. Drop this down and make this 150. And 24 will go into 150. Let me make this line bigger. 150. 4, 5, 6 times. So that would be 144. And when I subtract, I got 6. So I need another 0. 24 will go into 60 2 times. 2 times 24 is 48. Which when I subtract, I get 12. It won't go into 12, but it will go into 120. Yeah, it will go into that exactly 5 times. No, not 5. Yeah, is it 5? Well, that's it. So I subtract 120, and I got 0 remaining. There is my answer. All three of these are terminating decimals. We're just looking for the place value of the number farthest to the right. That will tell us in a fraction what the denominator is.
2/5.
So for example, write a count. Before it's 2/5, right? This is 4, and what's the place value of the 4? Tenths. So it's 4 over 10, which we would simplify by dividing both these by 2 to 2/5. And yes, that would be the answer, right? Count. Good luck.
Okay. So well, the answer is going to be negative because, well, there's a negative right there. And so it'd be negative, and then, so this is because it's out of a hundredths. So it'd be, so yeah, so basically that. So the answer would be negative 83 over 100. And then 83 can't be divided by anything evenly.
Correct.
Oh my god.
Alright, so on this one, there's a couple ways we could look at this. Now, using just the same method we just did on those last two, I'm going to write this number as it is without the decimal. That would be a 3, a 7, and a 5. It's negative, and that's okay. And then we're going to divide it by the place value. So I've written this number as it is. Now I need the place value of the 5 because it's the number farthest to the right.
Oh. Okay.
Then, so I'm going to make this over 100.
Make it divided by 20.
Now if you do this much on the test, you're looking at it 2. But you got to simplify it if you want at least a 3. So what would we divide both these numbers by?
25.
25 would be excellent.
Wait, why 25?
Because they're both divisible by 25. Which will allow us to simplify it.
Wait, why
Is that what
can't
it
we
is?
do like a smaller number?
Negative 15
Like 5.
fourths.
Could?
If you divided it by 5, you would find that you could divide it by 5 again,
And again.
which would give you these.
Okay, so you just want
Alright, so that is all. You should be able to get the answer either way, whether you divide by 25 here or 5. How do we know it's divisible by 5? Because they at least end in 5 and 0, both these numbers.
matter about this. I can get it right
Alright,
after
good
one
luck.
equation.
Wait,
Thank
can I
you.
do the next one? Okay, so which means it'd be 16 because it's 16, right? Okay, and then divided by the number the farthest right is a tenth, right? 100th, 100. So then you divide it by 100.
I have no idea.
Right? Is that right?
Keep going, yeah.
Okay.
Great.
And then a number they can both be divided by is 2. Okay, so 2. Wait, is it recording? Oh, hello everyone. 100 can't be divided by 4.
It can.
How many quarters does it take to have a
Could she have divided by 2 though?
Yeah.
She could have.
Okay. Okay. Well, I didn't know that 100 could be divided by 2. 4. Okay, anyway. Okay, so then 16 divided by 4 is 4. And then 100 divided by 4 is 25. Right?
No, it's 25.
Shut up,
Alright, nice
Skylar.
work.
Bye, guys. Thank you for
Excellent.
watching. Like and subscribe.
Like and subscribe. Good luck.
Oh, get up. Oh. Hello, everybody. So,
Do you have any scissors?
it would be 242 over 100. And you can divide these by dose. And so that would be 50 over 121.
Nice.
Yeah.
You wrote it right.
Bam.
Yeah, okay. We would say it's 121 over 50 though. Good luck.
Thank you. You got this, Austin.
Okay.
Remember, it's literally 2.
So we can put 65 over 100. And then it's 65 over 100. And then we can divide both of them by 5. And then you get 13 over 20, right?
I got 13 over
yeah.
20.
And then you get 13 over 20.
Excellent. Now this is a different way to show it because notice we just got rid of that decimal and just treated this as 65 over 100, which is fine when showing your work. Thank you. Good luck.
It's 3 hours.
Guys, quiet.
It's not on the. It's moving and it's not on the pen.
How do you make it on a pen?
I don't know. It's not on the pen. It's on the movie thingy. How do you make it on the pen?
You click on like the pen,
Pen?
the top one.
There you go.
Okay. So it's 3 hour. Nope.
Oh.
Oh, there we go.
Oh, and then click a color.
Black. Okay, so it's 3 hours, and then it's 12 minutes, but there's 60 minutes in an hour, not 100. And then that makes it 192 over 60. And then if you divide that by 6, so divide by 6, that's 32 over 10. Oh, and then that divided by 5 again. Wait, I mean, divided by 2, sorry, is 16 over 5.
Hey, can I please take a picture of this? Please.
Yeah, hurry up.
Answer.
Thank you. This is so small. I don't get it. I
Wait, what?
literally. It says decimal one.
Oh.
Well, you were gone.
Well, I don't. Oh. Well, then I did it wrong.
All right, so this is the simplified fraction, which actually helps us quite a bit because it will make the division hopefully a little bit easier. This is 16 divided by 5, which would be 3 and then 15 and 1 remaining. So I'm going to make that a 0, drop it. 5 goes into 10 twice. So that's 3.2 in hours.
Could you just use the 10 to bring the decimal?
One kilometer is approximately 0.62 mile. What fraction represents this length? So this is kind of what we did before, yes.
That's the answer?
But we got to look at why it is that. So on this one, we have the fraction, or the decimal rather, 0.62. Now this would be considered 62, and the place value of the 2 is in the hundredths position. So I would have 62 hundredths. That's how I'm going to start my fraction, but if I can simplify, I will. And I know I can divide both of these by 2, which would give me 31 fiftieths. I can't simplify that anymore. That's done. All right, this is 0.7 repeating. So I'm just going to say that x is 0.7 repeating. So I can show a few 7s to show that it repeats. Now to get this decimal past the bar, I need to multiply it by 10. So if I multiply that by 10, the x. So if I multiply the 0.7 repeating by 10, then I get 7.7 repeating. Something like this. And what we did to solve this, because we just want to get rid of that repeating 7, is to subtract both sides of the equal sign. So if I subtract 1x from 10x's, then I get 9x's. And this would equal 7 repeating minus 7 repeating is 0, 0, 0. 7 minus 0, 7. And then to solve, I would divide both sides by 9. That gives me 1x equals 7/9. Some of you guys know the rule of 9s, which would work especially on this problem. All right, this one we can use the rule of 9s because it starts repeating right after the decimal. So what number is repeating? 15 is. And how many numbers are repeating? 2. So how many 9s do I have? 2 of them. Bam. 15/99ths can be simplified by dividing both of these by 3. And that would give me 5/33. Done. Alright, so for 29, what I'm going to do is I'm going to move this, I need to move the decimal 3 times to get it past that repeating, or the bar, I guess. What this is going to do is, it's going to line up the decimals pretty nicely as well. So originally, I could say that x was that 0.342 repeating. But now I multiplied that by, I moved it 3 times, so it's like I multiplied by 1,000, which would give me 342.342 repeating.
Oh, okay.
Yeah, then we're going to subtract. So I'm going to subtract that 1x, which is also means I'm going to subtract 0.342 repeating, and then I see what I get. 1,000 minus 1 x's would give us 999 x's. The 2's, the 4's, and the 3's cancel out with repeating. And I've got 342 minus 0, which is 342. Now I will divide both sides by 999.
Wait, hold on.
Which will give me 1x, which is what I want. But I should be able to simplify that, 342 and 999. So if I divide it by 3, this is what I would get, but these are both divisible by 3 as well, yep. So as it turns out, as a fraction, 114 divided by 3 would be 3.
It would be 38 over 111.
Yeah, 38, very good, over 111. That's it.
Wait, could you just divide the first number by?
Alright, so on this one, we have 1 and this 8 is repeating. So I know my answer as a mixed number would have a 1, which means I kind of get to ignore this 1 right here. So I'm looking to get 0.8 repeating, which means, alright, so I'm just going to look at x being 0.08 repeating. So I can show a few 8's just to illustrate that. And I'm going to move the decimal over twice to get that, so I'm going to multiply that by 100. So 100 x's would give me 8.888, and then the 8's just repeat. So, when I again look to subtract these, 100 x's minus the 1x would give me 99 x's. And this equals 8's cancels, 8's cancels, 8's cancels. I got 8.8. But we don't want decimals in our fraction, so I am going to multiply both of these by 10. Alright, so I got 990 equals 88. And to solve this, I'll divide both sides by 990. So I got 1x equals 44 over 495. I can't simplify that anymore. So, that's it. Oh yeah, so let me actually put that back in there, right? Now, we don't want mixed numbers either, so that means we need to change this into an improper fraction. So I got 1 times 495 plus 44. It's still out of 495 fifths. So,
It's 539.
thank you, 539. That would be the improper fraction, which is really what we want.
Wait, that's the real answer?
So, once again, this one I'm going to do a little bit different. Here's the thing is we got 2 decimal places that are repeating. If I tried just to get the decimal past the bar, I would move it 3 times, but then it's going to offset the repeating numbers. So really I just need to move it the same number of times as the bar, as the numbers that are repeating. So I'm going to move it twice. So I'm going to say x is 4.532 repeating. And then I will say that 100 x's, because I moved it twice, the decimal, will equals 453.232, and then those repeat as well. So we're going to subtract these, that's a 1x. And then the 2's and the 3's cancel out. I need to borrow from these. So I got 12 minus 5 is 7. 12 minus 4 is 8. I got 4 48.7 equals 99x. We don't want decimals in our fraction, so we're going to multiply these both by 10. And that would give us 990x equals 4,487. Then just divide both sides by 990. That cannot be simplified. 4487 is not divisible by 3 or 9 or 11. So, that's our final answer right there. We'll just say that is the fraction. Write all number classifications for each number. For pi, pi is irrational. So that means 4 of them will still be irrational. It'll just be 4 of them. So it's irrational, which means it is also a real number. Alright, 15.2, this one is a terminating decimal, which means it is rational and also real. Negative 9 2/3, this one's a mixed number. It does show the fraction. We could make it an improper fraction, but we don't need to. It is simply rational and also real. 35, this one is a repeating decimal, which makes it rational and real. The square root of 14, that's not a perfect square. So that means this one is going to be irrational, which makes it also real. Let's look at our own example like E. They talked about E on one of the homework assignments. E, if you put in the calculator, you would see that this one is irrational, but also real. So what about some kind of terminating decimal? What do you guys want?
0.214.
0.214. Let's categorize this.
Rational and real.
Very good. This one is rational and also real. 2 different fancy R's. What about this one up in here? What about a repeating decimal like, what do you guys want? 17 point, let's make it negative even. 0.5214 and just the 14 repeat. How would we categorize these?
Rational and real.
Correct. Rational, real.
That's a cute.
Let's try a proper fraction, such as, you guys give me a proper fraction up and count.
What's a proper fraction?
1 and 3
Oh. 1 3/8? That's a mixed number. Still matters.
2.
2/4. Well, this is a fraction, so automatically it should be considered rational and real. Alright, let's do 2. Let's maybe make it negative. What the heck? No, let's not make it negative. 2.
Whole, rational, and real.
Alright, so before we talked about natural as well, but yes, that is correct. Whole.
If we didn't put natural.
Natural.
If we didn't put natural, would it be wrong?
Oh, I forgot integers. Yeah, integers. Rational and real. Alright, what about something like negative 14?
Integer.
Yeah, this one's an integer. Is it whole?
No.
No, because it's negative,
Real.
then rational,
Real.
then real. What about one more example on it, these? Let's do the cube root of, what do you guys want? 10. How would we classify these?
Irrational and real.
Correct. Irrational and real. There it is.